Hello, you are welcome to Coding with Joe. So today we'll be looking at how to deploy our smart contract. So in our last video, we created this test token that we are going to use as our stablecoin. So let's see how to deploy this on the Polygon Mumbai chain. Okay, let's look at the deploy script that came when we initiated our hardhat project. So let's copy everything. I just like to do this because it's faster. So let's come back to script and we create our own deploy file. So let's call it deploy underscore show underscore token dot ts. So let's paste this here. So we are going to allow this here. As you can see, we recommend this pattern to be able to use async await. So apart from that, let's remove everything from this function. So we have this. The first thing to do is to import our hardhat runtime environment from hardhat. So we do import hardhat runtime environment from hardhat. Yes. Okay. So the next thing is to get our contract factory. So to do that, we need to get our contract. So we use the contract factory from ethers.js. So let's do cons. We can call it show test token equals to await ethers dot get contract factory. And this contract factory takes in a string, which is the name of our smart contract, and it needs to be the same name. So let's copy the name of our smart contract and we paste it here. So the next thing to do is to deploy our smart contract. To do that, let's call cons record. We now spell it with a small case C, show test token, which is equals to await. We call this our contract factory dot, oh sorry, we call our contract factory dot deploy. So if we now look at our contract, we see here that we expect a cap, a cap value and an address. So when deploying, we need to pass those. So to pass this, since our smart contract expect 18 digits, so to pass this, we are going to use ethers again. So we do ethers dot pass pass ethers, so we can convert values into it. So and it takes in a string. So we can pass 40 million for our contract. Let's see, 0 1 2 3 1 2 3, and let's just put dot is zero at the end, and then here it now expects an address. So you have to put the address that you have in your .env, the same wallet address that you have the private key in your .env, because that is going to be the private key that we use. So let's go to our smart to our MetaMask. Go to your MetaMask and get your address. I'm getting mine now. Okay, so I have mine and it should be in a string. You paste it there. So this address is the address of the private wallet address, the private key that I have in my .env. If you check um, the previous videos, the one that we were setting up hardhat, you will see how to provide your private key. So the next thing to do is now check to check the deployment. Okay, so let's log in the address so we can have access to it. So after deploying, we can do console.log and we do show token address. And we call await show token address dot get address. Okay, since we are using ethers.js version 6 as from hardhat, so if you n- if you are versed with version 5, you will notice that this is not how to is being done to get the address. But after this series, I'll be doing a new playlist whereby I'll be showing the differences between ethers version 5 and ethers version 6. Okay, so with this we can deploy our smart contract. But right now, what I want is to also verify it using polygonscan. So to do that, there's a requirement that has to be met, which is the smart contract must be on the blockchain for at least 5 minutes. So we are going to be creating a sleep function that will pause this process for at least 5 minutes. So to create that sleep function, we have function sleep, and the sleep takes in number, which is the millis and seconds. And since we are using TypeScript, we put the other type, and we return a new promise. Return a new promise. Sorry, return a new promise. Yes, which takes in the resolve and the set time. So we put the resolve, set timeout, and it takes in the resolve and the millisecond. So this is our sleep function that we have. So yeah, we can now call the sleep function, but before that, let's log in sleeping. So let's now call our sleep function here. So to we call await sleep, and we give it 400 milliseconds. This should be about 6 minutes, just to be on the safe side. And after that, we now have to verify it on the blockchain. So call await, and to verify it, we use hardhat runtime environment dot run. And run takes in verify, have the verify, and this takes in two parameters here. We have the address that you want to verify, which is we get it from our deploy token get address, and also the constructor argument, constructor, and also the constructor argument. And this takes in, and this is an array, and this array needs to be the same with our constructor. So let's just copy this and we paste them here. So that is it. We are done with the code. So now let's try to run the code and deploy. So first thing you save. Let's do npx hardhat compile to make sure you don't have any problem. So you see it runs well. So to deploy this, we need this command. So you're able to find this in the description section, which is npx hard run, the network, then the script and the deploy script. So let's copy this, paste it here, and we edit this. So we have M- npx hard run, network is mumbai, script, and our script is deploy underscore show. I text if you click on tab, it gives you the name, and then you click run. So once it's running, it's going to deploy. And let me put in our address here because we will need to use this to see our contract on the polygon scan. So let me copy. This is our address. This is the address of our smart contract. So I've copied it and let me paste it here. So we are going to use this in the front end too. So I will get back to us when we are done with the verification process. So we can see that our verification process was successful. So let's copy our contract address and go to polygon scan. Okay, so let's search for polygon scan and we choose Mumbai since we are working on the testnet. Sorry. So the next thing to do is to put your contract address and you search. So if your contract has been verified, you will see this green tick here. So when we click on it, if you go under read contracts, you can see the allowance, the balance of our cap. You can see it's 40 million. The decimal, the name of the project, you can see it. The owner of the project, that is it. So most of these functions are from OpenZeppelin ERC20. And if we go to the right contract, we can see the approved contract, the renounce ownership, the transfer and transfer from and transfer ownership still from OpenZeppelin. So these functions are on all stable coins. So we'll be able to use these functions even on Polygon, USDC, DAI, and so on. Any stable coin have these functions. So if you want me to do a playlist on the differences between ethers.js version 5 and version 6, please put it on the comment section below and also subscribe. See you in the next video. Thank you.